Thank you for introduction, but I directly go to my presentation, which will be about the flora and vegetation types of high mountains of Iranian mountains. Iran is located in Southwest Asia, meeting point of two global biodiversity hotspots and 3 biogeographical regions. Major parts are Irano-Turanian region, northern part Euro-Siberian, and southern part Saharo-Sindhian phytogeographical regions, and Caucasian biodiversity hotspots are north, and Irano-Anatolian biodiversity hotspots are meeting here. Biodiversity hotspots are the regions where the number of endemic species are very high, at least should be 1,500 endemic species, and at the same time, the region is highly endangered by humans. And there are 36 global biodiversity hotspots, which 2 of them are reaching to each other in this region. There are many high mountains in the area. As you can see here, I divided them. Alborz in the north, Iranian Plateau, Zagros, the biggest one, Kerman Mountains in south central, and Kopedag Mountains in northeast. And as you can see, this yellow part is Irano-Turanian region. Caucasian and Saharo-Sindhian, the southern parts are. And here is the map showing global biodiversity hotspots. The situation, high elevational amplitude, topographic complexity, and different climatic areas, heterogeneous climatic situations, resulted different vegetation types, from hot deserts in central parts of Iran with very, very low precipitation to Hyrcanian forests in northern part of Alborz Mountains with high precipitation, reaching to 2,000 millimeter per year. And in central part of the montane zones usually are shrublands, oak woodlands in Zagros Mountains, Subalpine and Alpine vegetation types that we will see all of these vegetation types in the next slides. One of the best examples to show different vegetation types in elevational zones is Alborz Mountain, North Iran. We are looking from west to east, and here is Caspian Sea, central part of southern slopes of Alborz, and the highest summit of Alborz, Damavand, 5,671. Different climate in different slopes and aspects resulted different vegetation types. And as you can see here, high precipitation in north face of the Alborz resulted Hyrcanian forests, and the dry parts, southern slopes with very low precipitation resulted halophyte desert vegetation types. Then steppe shrublands, a bit higher elevation in the montane zone. In subalpine zone, tall umbelliferous plants, vegetation types, and thorn cushion vegetation types in alpine habitats and subnival vegetation types. There are around 8,100 vascular plant species in this area, and 32% of them are endemic. And here we can see the biggest families and the number of endemic species in each family. Astraceae, Fabaceae, Poaceae, Brassicaceae. Fabaceae is very big. The number of endemics is the highest, and it is because of the astragalus. Astragalus in this region is very rich. And as you can see here, around 800 astragalus species are only in Iran. and the majority of them are endemic, as you can see here. Most of them are endemic. And then the next biggest genus is Cousinia from Australia, also with a lot of endemic species, which you can see detailed information in this publication we published a few years ago. Astragalus is the big genus, as I told you, with different life forms, with different shapes, and in different elevations. It is covering everywhere. You can find even 6, 7 species, sometimes in one plot, Astragalus species. And some of them are difficult to determine. And this is the Cousinia with 280 species. Endemic species of Iran are mostly in mountainous regions. As you can see here, high elevations. The central part are usually deserts, and the number of species are poor here, and endemics are very poor. But these areas, the high mountains, are very rich, and we divided the number of species in each mountain range. Alborz, Zagros, for example, and as you can see here, the species which are only in one mountain, for example, in Alborz, we are showing with the dark gray, and the endemic species of the region which are reaching to other mountains, we show with the light gray color. And as you can see here, Zagros has the highest number of endemic species, its own endemic species, and then Alborz with 400. But look at the area size of the mountains. Alborz is almost the smallest one in the area size, but the number of endemics is very rich. And this is because of its topographic situation, very high elevational amplitude, and also very different climate in different aspects. And here in grid cells, we show the number of endemic species of Iran in each grid cell, and the richest one is in central Alborz, and then in central Zagros and south Zagros. As you can see, these mountains are very rich, and usually these areas have the highest elevational amplitude. And something very interesting, which is almost everywhere the same, but here is sharply we can see that rate of endemism increase with elevation. As you can see here, we divided the non-endemic and endemic species for different elevational bands. And as you can see here, the lowest elevational band, lowlands, the number of endemics are just 8%. Then a bit higher elevation in this elevational band, almost 40% of the area size of the country covered in this elevation, but number of or proportion of the endemic species is only 17. But go to the highest elevational band, Alpine habitats. Only 1% of the region is Alpine habitat, about 2,800, but 7% of the endemic species of the region are in this zone. This is why we believe that Alpine habitats of the region is hotspot of biodiversity, not because of the number of species, but because of the number of endemic species. Now, different vegetation types. I start from lowlands, from deserts, show a few plants and a few pictures. As you can see here, this part, central part, is surrounded with high mountains. And the precipitation in this region is very, very low. In some parts is lower. This graph belongs to just northern northwestern part, the edge of the desert. So this is still the better situation, but we have some regions, for example, this Lut Desert in southeast Iran, which precipitation is very, very low. It is one of the driest and hottest deserts in the world. If you search, you will find this name. Lut means bare, bare without anything in the local language. And you cannot find easily plants. And animals are also very, very rare here. And it is a huge region. For example, you can see it is just here, 200 kilometer. And this is structure, what we can see here, this is here we can see, it is because of the wind erosion. It made very, very big, I wouldn't say mountains, but hills in this situation. And the photo that I take here is just edge of this desert. And close to mountains, because this part, here is this Lut Desert, and then mountains in western side reaching to 4,000 meters. And then we have vegetation types from here going to the high elevation, subalpine and alpine also. And this is one of the species in the desert, this endemic Tamarix kermanensis. And yeah, this is an interesting plant just between the desert going to the mountain, not related to the vegetation types, but this Cupressus sempervirens, it is very, very old tree. 3,000, it's mentioned 3,000 years old tree. Just when you drive from desert to this high mountains in 2,000 meters, there is such a beautiful tree. So, haloxylon shrublands. It is very common. They are big trees. Tree I wouldn't say, but somehow shrubs with very low precipitation, very, very salty, but yeah, it's dominant, and biodiversity is rare, but still there are some beautiful and interesting plants like Cistantia tubulosa, which is widely distributed, and this endemic Linaria michauxi, endemic to Iranian deserts, and also animals which are active usually night or early morning. And also some halophyte plants like Nitraria species or Raumuria, which is one of the last plants in the salty parts. And then when we go a bit higher elevations, precipitation a bit increase, we have semi-deserts or steppes. Dominant species are usually Artemisia and Stipa. And there are some species we can see here, some places dominant, Ebenus stellata or Convolvulus leucalicinus. And a bit higher, beautiful bulb species like this Tulipa micheliana, which is endemic to northeast Iran, Kopedag Mountains, or this Fritillaria gibosa. It's very small, tiny, but very beautiful. Coccinia macrantera from Borraginaceae, Rosa persica. It is very small shrub, Rosa persica. And also Cleome colutoeoides, for some example for this zone. Also, there are isolated or scattered habitats, Gypsophilus hills, which has its own flora, and somehow hylophytic species are also living in this vegetation types. They are distributed mostly in northwest. Very beautiful structure. Geomorphology is very beautiful, and also interesting plants we can see there, like this Caligonum junceum or Glaucium flavum, Ochrandenus ochradeni, and also Iris songarica, which this is widely distributed in semi-desert habitats. Salvia limbata, Allium scabris capum, and also this Hedisarum species that I couldn't determine till now. And also there are very beautiful structures and beautiful places for animals to live like this. And now we go a bit higher in this vegetation types, in the higher elevation, close to subalpine zone, but still between the species which are distributed in Montane to subalpine zone, like this Tulipa species, Tulipa cistola, Tulipa montana, Tulipa biodiversity, or some beautiful iris species, Iris reticulata, Iris iberica, and Iris meda. A different vegetation type, western side of Zagros mountain, receive a bit more precipitation, and then it is the situation for developing the woodlands, oak woodlands in this area. It's not compact forest, but woodlands. And there are 3 different Quercus species in these forests, but Quercus persica is the most dominant one. And there are also some beautiful species, some of them rare and endemic, local endemic, like this Allium straussii, very local, and Campanula cecilii, a bit widely distributed in Zagros, and some of them are like this orchids, a bit widely distributed. Then a bit higher elevation in entire Iranian mountains are covered with Juniperus excelsa woodlands, usually from 2,500 to 3,300 meters. As you can see, they are scattered, not so compact vegetation type, but there are sometimes very old trees. And in most of the regions, they are destroyed, and vegetation types are covered with another vegetation type that I will show you later, umbelliferous vegetation types. These are used during the last centuries and also millennia. Also, you know, the region has a very long anthropogenic activities, grazing activities, and this kind of forests are in most of the regions disappeared, but some regions still we have this vegetation types as forest. And also in these areas we can see some local endemics, Tulipa ulophila, for example. Now we go to the northern side of Alborz mountain. which precipitation is high, Hyrcanian forest. Some dominant species are Fagus orientalis, Carpinus betulus, Quercus castaneifolia, Quercus macrantera. These forests have some relict species from tertiary periods like Parotia persica, Gleditschia caspica, Zelkova carpinifolia, and Petrocaria fraxinifolia. Most of these species were widely distributed in northern hemisphere in the past, but because of the glacial periods, they disappeared and only remained in Hyrcanian forest. Therefore, these forests are very important for conservation aspects. You can see these trees, Parotia persica, Quercus castaneifolia, distributed only on this region, and Quercus macrantera, which is a tree in the border of forest to grasslands, forest line tree, Quercus macrantera. I will talk about this a bit more. And some bulb species in this elevation, Fritillaria kochiana, Galanthus transcaucasicus, and Fritillaria rhadeana. And this is big Fritillaria, very close taxonomically and phylogenetically to Fritillaria imperialis that I will show you in the next slide, distributed in Zagros mountain, but here is Alborz. And the only Lilium species in Alborz, Lilium ledebori, very local. It was described just a few decades ago. It is very rare. And this Paonia wittmanniana, the only Paonia in Hyrcanian forest. And yes, a village in the Hyrcanian forests, people, their custom. Now we go to the forest line or tree line, but I will tell you why tree line we cannot say here to this zone. You can see the forest is finishing, and then we have grasslands. But the elevation here is 2,500 almost. This is Quercus macrantera. These areas, usually where the Quercus macrantera distributed, usually also is covered with this Papaver orientalis or Cardus seminodus because of the anthropogenic activities. The trees are disappeared and these plants are dominant now. Galanthus transcaucasicus, also it is in this zone, tree line zone. Now, you see the Hyrcanian forest reach to 2,400, 500 meter, and in some areas, very small patches, we can see also some trees, but usually they reach to this elevation. And these areas are usually very steep and rocky habitats. Around 10 years ago, it was 2010, yes, I was in a congress in Switzerland, and Christian Körner, maybe you know him, Alpine ecologist, was organizer. I presented Iranian alpine habitats and mentioned that a tree line zone in this forest, in Hyrcanian forest, are 2,400, 500 meter. So he told this cannot be true because tree line, he has a book about tree line in the world. Yes. He told this is not tree line. The tree line should be climatically somewhere which is very cold, and Quercus species cannot be tree line species. It should be conifers. And it was a point that we started to do a study in this forest because they had a publication showing that tree line zone in different parts of the world has soil temperature 10 centimeters below ground in the growing season has around 6.7 degree. And this is almost everywhere similar with some deviation. So I put temperature loggers in this zone. You can see in the soil and also in air, but this is important. And we found that it is too warm, 11 point something. So, and we calibrated with this, in which elevation it should be 6.7 as other regions, and it should be 3,200 meter. It should be tree line zone in these areas, okay? But why we have tree line till this elevation? So this was a question. Our interpretation was, you can see this photo. This is again 2,400 meter, the same area. What can it be? What do you think? This is trampling or grazing of the animal's herd, and this is very, very, the tree species cannot easily generate here, yeah? Regenerate. And as we can see here, the Quercus species also can reach to 2,850, but in the region with grazing is not so strong because they are very steep, rocky, and scree, and it's not good place for grazing. Therefore, this elevation from 2,400 to this elevation, 2,800, there is no tree because of the anthropogenic activities, overgrazing, and so on. But we told that tree line should reach to 3,200 meter. But why there is no such a trees there? The reason is that there is no conifers in this forest at all. Taxus baccata, but it is in lower elevation. It's not tree-line species. There is no Picea, there is no Pinus, and no Abies, Larix, and it is not because of human activity. Paleobotanical studies shows that there have never been these trees in the region for 200,000 years ago. Okay? Therefore, now we have two reasons for not having tree line in this area. Absence of appropriate taxonomic trees and overgrazing. Yes, as you can see, impact of human. Now we go to another vegetation type, umbelliferous subalpine vegetation. They are big plants around 2 meter and sometimes 3 meter, very huge. Mostly ferula, prangos, ferulago, and these kind of species are dominant, as you can see. And more likely, this is also, they are dominant because of the overgrazing. They are successful because they are not well eaten by animals. You can see here, Diplotania cachridifolia, an endemic species and genus for the region. Also, Rheum ribes belongs to this vegetation type. And there are some beautiful species in this zone, Papaver bracteatum, Papaver lasiotrix. They are very big, very huge papavers. And they are very close to Papaver somniferum. You know this plant probably, yeah? And local people also use it. The quality is not so good, but still you can use it. And this is also Papaver orientalis, a bit smaller than others. Yeah, Iris barnumae and Iris acutiloba, a few species, iris species which are in high elevation. This is the highest iris species in Iranian mountains. And this is Tulipa humilis, the highest tulipa reaching to higher elevation, subalpine, alpine areas, Tulipa humilis. Very beautiful and very variable in the color, as you can see. Eremorus spectabilis. Yeah, one image for the subalpine wetlands with some character species like Ranunculus kochi and Muscari armeniacum. Pushkinia siloides is also a species in close to wetlands or snow beds, but not in alpine, in subalpine zone. And this is Fritillaria imperialis, very beautiful Fritillaria, very, it's big. Flowers are very beautiful in two colors, red and yellow. And some areas, they are very, very dominant and attractive for botanists and ecotourists from different parts of the world. And this is tiny Fritillaria, Fritillaria reuteri, very local endemic, as you can see. Very, very nice color, but small. Now we go to alpine habitats. There are around 700 alpine species in Iranian mountains, but majority of them are endemic. You see, I told there are 8,100 vascular plant species, 32% are endemic to Iran. 700 alpine, most of them are endemic. And the reason is somehow clear because alpine habitats are in higher elevation isolated, and in isolated situation, the rate of endemism is higher. And look, the floristic connection of the alpine habitats of Iran with other mountain ranges. We analyzed this, it was my first paper, 2008. And interestingly, you can see that European alpine species, there are only 6.5% common species between Iranian alpine and European alpine species. But the most closest one are Anatolia, Caucasus in the west, and Afghanistan and Central Asia in the east. If you wide distributed species, alpine species I show you, you know this probably, Oxyria dugina, widely distributed alpine species, usually in scree habitats. And I saw it, of course, in Alborz, you see, in Alps and Iceland. But look at the elevation of their habitats in Iceland, because it's very close to it's in northern latitudes. Alpine habitats are in lower elevations. Alps, 2,600, I would say the optimum elevation, and in Alborz, 3,600. Another similar, I would say, species with the distribution, similarity in the distribution, is Erigeron uniflorus. Look, this is southern Iran, Zagros. This is Alborz, Caucasus, Alps, and again, Iceland. And you look at their elevation. But this species has different subspecies, and some taxonomists believe that they should be separated. For me also, this species, it's named Erigeron uniflorus subspecies denaensis, and this one subspecies elburzensis. For me, they are different, and the habitat is also different. This one is in snowbeds, and this one is in scree and rocky habitats. Habitats are also very different, and morphology also. So I think also they should be divided as different species, but they are very related to each other. And this one is Androsace villosa, widely distributed in Western Asia and Europe. In alpine habitats also there are many endemic species. I told you more than 50% of species are endemic, but also several endemic genera. Most of them are from Brassicaceae, some Apiaceae, and also Caryophyllaceae. Alpine vegetation types. A few slides about the alpine vegetation types. My plots, I collected only high elevation habitats, vegetation types, and I analyzed. The major vegetation types are these four. This is subalpine, umbelliferous vegetation type that I mentioned. This is thorn cushion vegetation types, snowbeds, and scree vegetation types. And we can see also in the ordination, they are well separated from each other. Now look at the thorn cushion vegetation types with a few species like Onobrichis cornuta, this pink cushion, and Astragalus macrosemius. They are together usually, but in some parts, I don't know what is the exact reason. Onobrichis is dominant, and in some parts, Astragalus is dominant. So look at here. So here is Onobrichis more, and here is Astragalus. It seems when the angle or slope change a bit, but I'm not sure if this is the reason. Another genus which is very important for thorn cushions, Astragalus is very important, Onobrichis. Astragalus has many thorn cushion species, and also Acantholemon is very, very important, having many species, around 80 species in the region, mostly endemic. And you can see how thorny cushion they are. And snowbed vegetation types. Usually they are patches surrounded with thorn cushions, with its characteristic species like Taraxacum brevirostre, Catabrosella parviflora, and some Polygonum serpilaceum uniflorus, Erigeron uniflorus. You can see how their morphology, rosette shape, adapted to this snowbed habitats. But I want to show you here that how thorn cushion vegetation types and the snowbeds and different vegetation types in these habitats are distributed because of the snow cover duration. Look at here, the elevation is 3,700 in Alborz Mountain, early June, mid-June, early August. But still in early August, some snow remains. Here is exactly this place. I took the photo from here and showing this part. See, this is the northern slope and the snow remains. Snow melting time in this habitat result very different vegetation types in this gradient. Look, I put temperature loggers in this gradient, and as you can see, the growing season is very short, long and longer, and then this parts in the edge of the hill, this ridge, top of the mount, snow cover even in winter time in this elevation is not so much, or there is any. Because of this, we can see soil temperature is below 0, 10 minus. Here is 0. It means that there is a deep snow cover, yeah? But here there is no, and it means that there is any snow cover, because snow is very, very well isolating the soil from the cold temperature. This results different vegetation types in the gradient of the snow melting time, and we have such a classification. This paper we published 15 years ago in phytocenologia, classifying different vegetation types. And this is in Central Alborz. This one is in northwest Iran. This paper was published 2017. But the structure is the same. If you have a look, species are different in some of them, but mostly, again, we have the same genera. Look at here, Jurinella moschus. Now the association is Jurinellatum. Here is Jurinella frigida. Acantholimon here is Demovandica. Here is Acantholimon sahandi. Because of the isolated situation in these areas, species are evolved, and we have different species, but they are phylogenetically also closely related. Probably they were once one species, and because of the isolation, the speciation happened, and we have different species in the same habitats, but different geographically a bit far away alpine habitats. One, different vegetation types, three vegetation types of high alpine and subnival zone. The dominant species here is, for example, Senecio taraxacifolia. For this type of vegetation type, which is close to Talaspiete in Europe or Heldreichiete in Anatolian mountains, 2014 we published a new class, Didymophysa dracocephalete auscheri. Because of the high elevation, isolated situation, the number of endemic species are high. Therefore, it could be a separate class, but it is similar in the habitat type to what we have in Anatolia and also European mountains. We described different vegetation types, associations, alliances, orders in one class. But I just move to next slide, show a few important character species of these vegetation types, like this Didymophysa auscheri, endemic to entire Iranian mountains, Dracocephalum auscheri, Alborz and Northwest, endemic, and Phyzoptachys gnaphallodes, again endemic in all alpine habitats of Iranian Plateau. This Euphorbia auscheri is also dominant in these habitats with very interesting structure adapted to moving scree habitats. You see how the below ground parts of this plant is. It took a long time for me to reach the root, and still I couldn't reach the last part, but you see how it is adapted. They are moving screes, and it is a flexible plant, can be moved with the screes, which when they are changing the position, the plant also can change. A few local endemics, Veronica paederota, a very special Veronica. In the picture you cannot easily determine it is a Veronica. And this endemic genus, Zerdana anconioides in Zagros Mountains. And another species that I found myself in Sahand Mountain, we named Nepeta sahandica, a new species for science. It was exactly in these slopes here, you see, very difficult to reach. Usually botanists don't go to such dangerous places. Therefore, I'm lucky to find sometimes some new species in such areas. And this species also, Senecio subnivalis, and it is an annual species, very small. Look here. I found it. I found it 2010 as a new species in a mountain, South Iran, isolated, surrounded with desert, in this elevation. It is just below the summit. very small, and it is alive for a very small time. Therefore, it is not. It has never been found before. And this one, another isolated mountain in central Iran, Shirkuh. Top of the mountain is 4,070, and I found this species in this elevation. It is also very rare. We had a long time we spent to determine it, and finally with the molecular analysis and so on, we found it it is a new genus, or we described as a new genus for the science, as Yezdana, because the region is Yazd, and Shirkuhensis, species name, we named to this mountain, Yezdana Shirkuhensis, Yazdana. And as you can see, it is very small. When I found it, 2010 it was, my first trip, or 2012, I'm not sure. We worked on it, and then we wrote a paper. Reviewer told you have few samples and it should be collected again, and I went there to find it. It was very, very difficult to find, and I spent a long time just to find some samples. Because it's very small, of course the population is very small, but also it is difficult to see because it's very small and the color is not so shiny. But in detail, it's very beautiful if we look with a close-up camera. And now, rocky habitats. In high elevation, I give a few rocky species, important ones like Dionysia, probably you know, or gardeners are very, very attracted to this. They like it and usually plant it. This is an endemic genus to Southwest Asia with around 50 species. Most of them are in Iranian mountains, 37. Although in Alborz is only one species, the rest, most of them are in Zagros and a few in Kerman Yazd. And you can see how different species of this genus are distributed, but the hotspot is Zagros, central Zagros. A few example, all of them are on rock, very close to Primula. And Dionysia archibaldi, this one is, Dionysia diapensifolia, Dionysia khatami, I saw 2 years ago. You see, it is again in central mountain of Iran. And this one, again, in the same place. Dionysia giantina with white color. Another very beautiful rocky species is Paraquilegia cespitosa. I have seen it only once. It is very rare species, and very difficult to take photo. It was not easy to take photo from this. I would love to see it again. This genus is an interesting genus, actually distributed in Central Asia and Himalaya, having around 13 species, and only one species is in Central Alborz with such a long gap or disjunct distribution, which is probably it was widely distributed before and during the glacial periods, and it's disappeared in between in the Hindu Kush Mountains and Kappadoc Mountains. And this is Veronica auscheri, the highest vascula plant in Iranian mountains in Alborz that I found. About this, we don't know any vascula plant. 4,850 this elevation, and I also put a temperature logger in its habitat to see how is the situation. And as you can see, very, very cold situation in winter time, short summer, and also summertime is also very cold. So a few slides about the threats of the biodiversity. The land use is very problematic here, especially overgrazing in high elevation, because the region during the summertime is very dry, lowlands. The only green parts is alpine habitats, and all heads of the region on sheep and goats move to higher elevation. Therefore, we have a lot of animals in this elevation, and it can easily endanger the vegetation types, and we can see the changes already. You see, these yellow plants, they are of euphorbia. They are overgrazing indicators. They are not eaten by, they are poisonous, not attractive for sheep, and therefore they are successful in these habitats. The elevation here is 3,500 in Dena, and as you can see, most of the species are euphorbia, Cirsium, Cousinia, which are spiny, and the natural grasslands are almost here gone. And climate change also is very important, impacting alpine habitats everywhere. But in this region also, recently we published this paper this year that's showing that the endemic species of Irano-Anatolian regions are highly endangered because of the climate change, using the species distribution modeling, and we found that most of the species lose their appropriate suitable habitats. Especially alpine species lose more. And also we found that we categorized species to 3 different elevational zones: lowland, montane, and alpine. And we found that in alpine habitats, the number of species will increase in the future. The reason is that the species from lowlands will move to high elevation. This is, of course, species distribution modeling. There are other factors which has impact, but based on this modeling, we found that yes, alpine habitats will lose most of, alpine species will lose most of their habitats, and the major reason, just compare it with the Alps. It's very different because in Alps, still we have a lot of alpine nival habitats, which species in the future can move higher elevations. But in this area, the only area which exceed the vascular plants limit is this Dama vent. Here is the upper limit of vascular plants, as I told before. We don't have alternative habitats for species in the future to move higher elevations, yes? Compare it with Himalaya or Alps, which still there are alternative habitats in the future. So this is another pressure for the region. And human, indigenous people in the area, some nomad, Shahsavan people moving from one region to other region, and from lowland to high elevation in summertime, with very simple life. This local nomads are in northwest, and Bakhtiari nomads are in Zagros Mountains, with very beautiful costumes in the wedding party, at least, which is very close to the nature of the region in central Zagros, to fritillaria, yellow, red, and so thank you very much for your attention, and I hope you are not tired after such a long waiting. Thank you.
Yeah, thank you, Jalil, for this wonderful pictures, really beautiful and very informative talk. You really did a lot of work in the Iranian mountains. So now we can have some questions. Well, I start maybe. So you show those woodlands with Juniperus excelsa, which are like scattered individuals, and between them there are like steppe or some kind of grassy vegetation. And I wonder to what extent these are determined by grazing. You mentioned grazing, but do you know some situations where Juniperus excelsa is growing, but grazers are not allowed to go there, like fenced areas? What would happen? How would be the succession in this woodland?
Thank you for the question. Actually, it has not worked. Just we cannot exactly say what happens, because this tree, you know that it takes very long time to develop, and in the nature it has not worked. But what we can see, the remote areas, which are especially in the northwest, which are less impacted by human, these forests are very dominant. So based on this, we say if maybe it is not the reason, or grazing and so on, which impacted this tree to reduce. But there is no study that I can say. It would be nice to just make a protection for some region to see what will happen to the area. But there are hypotheses that not only grazing, but also cutting the trees in the for fire and so on. Because when you do this, it is for these trees are usually very old, and they cannot easily generate. And when they are small, a bit trampling also impact them, and they cannot easily, yes, grow.
I wonder why cedrus is not distributed from Anatolia there.
Yeah, good question. I don't know. Yeah, I have no idea. Yes. So yeah, maybe.
Like no, I don't know, but anyway, it was like really interesting what you said about the absence of conifers in the Alpine belt. Because it's quite unusual if you take Asia. So in the Western Caucasus you have Abies normaniana, Pizza orientalis. Then in Central Asia you have Pizza schrenkiana, for example, in Tian Shan, and this area is like without subalpine conifers. Why? So
interesting question, open question actually. We don't know why. And but this is more likely it should have a climatic reasons. Maybe it is too dry. I don't know. Of course, the Hyrcanian forest has a lot of precipitation, but probably in one period it was this zone was drier. They had disappeared and never could come back again from the Caucasus or Central Asia. But I don't know also how it's possible to find the reasons. I mean, it would be interesting to find a methodology to see what could be the reason for such a.
Yeah, of course, it's always difficult to give some reason for something being absent somewhere. So, no.
Maybe speaking about number of species and endemics, it's important how taxonomic research is organized. So can you tell us something about how the research or the taxonomic research is organized? Whether this is rather local or focused on some mountains, or whether there are some larger studies of the whole region, and how much critical the data are, or how much accurate they are, or whether there are some biases possible. So on. Thank you.
Actually, Reschinger, you know, he wrote the Flora Iranica, and he was a person who described many species, which some of them were not good species. And he believed that, yeah, I describe, even he had also doubt, he described, then people, later botanists could go and search more to see if it is real species or it is close to others. It was his strategy. Based on this strategy, the other botanists also followed him somehow in this region. So they, even in Turkey, even worse than Iran, I would say, there are many species published, which they, in the last years, for example, based on the molecular analysis, they are synonymized and combined. But in general, it is not that much that we can say, yeah, 10% we can say, yes, there are such problems. But on the other hand, we made another study based on the alpine habitat species, and we saw that still there are many species which are not described. In this, we modeled this 2016 based on the rate of the description of the species, and we saw that still there are 7% species which are not described for the region. So yes, some species that I mentioned, 2,600 endemic species, partly will be combined, partly are not good species. On the other hand, there are species which are not described, and every year botanists are describing. So, but I would say, yes, there are bias in the taxonomy.
And did you also model the rate in which like already described species are cancelled, merged, or?
No, this one, I didn't do this, no.
Okay.
Because I did on alpine habitats, this model, based on the history of the description and how the rate of the description increase in the time. But usually in alpine habitats, we don't have this bias so much, because in high elevation, the botanists who just want to describe, they usually go with car and find in the somewhere something and then describe. But usually they don't go for high, it's difficult to go high elevation in this region. And usually the botanists who are real botanists, yeah, they are careful. So I'm not, I'm mostly, yeah. So. Was not my mean, but yeah. The bias in alpine habitat.
Other questions? Yeah, tell us about logistics.
Yeah. Mostly, yes. It is. There are some places a road to drive to 3,000 meter, but if you want to go to 4,000 meter, of course you have to hike and camp in the high elevation a few days. Yes. Yes. No, north, you mean the alpine habitats or this Hyrcanian forest? Yeah, it is very high because of several things. One I showed you, the overgrazing is very, very harsh, and also cutting the trees. The tree is very expensive here, and it is protected somehow. But it's difficult to protect, you know. In the region which economy is not well developed, you can imagine that people cut the trees and destroy the habitats, or they make farm for themselves. This is a big problem in the region. And in the last decades, the size of the natural Hyrcanian forest decreased a lot. Yes. What about plantation? Yeah, the plantation is also done for this region, but it is not, they used usually, for example, Pinus nigra, which is not natural for the region. And this is not helpful. They made the flora of the region problematic, and they changed the soil structure. It was not scientifically well organized to do the reforestation and so on. Yes. And now it is a big problem.
And do you have some native large herbivores in the alpine zone? Like I think the sheep and goats. So because this is the region where the domestic sheep originated from, isn't it?
Also goats. Yes. Yes, especially in the protected areas, where I showed this new genus. If you just hike in this mountain, you see a lot of wild sheep and also goats. But they are usually mostly in protected areas, because in other regions are disappeared. Just imagine there are many hares and sheep, human, and they cannot be close. They are restricted to the protected areas. Yes. Yes?
I've seen or heard that Iran is also facing a water shortage due to a lot of taking out water for agriculture.
Yes, yes.
Does this already have effects on the natural vegetation that you were studying?
It has impact, of course, but it takes time. I never could scientifically work on it, but there is a lake, very huge lake in northwest. It is drying and it is full of salt, salty lake. It is one of the biggest salt lake in the region, and this is now dry. And that these vegetation types, which are before was only hollow fights were around the lake, but now this, because of the wind and a lot of salt, moved to the mountains, and this easily will change in the future the vegetation types. We can see this, but I never had a chance to study what happened. But for sure it will have huge impact.